In the second problem, again, we have a double integral, which is very difficult to integrate unless we do something, we change something. And the integrand here invites us to consider switching this integral into polar coordinates. In order to do so, we have to check what is the region of integration. So as you can see, y is bounded by x and square root of 18 minus x squared, and x is bounded between 0 and 3. So let's see what this region looks like. Okay. Okay. First of all, y is equal to x. That's straightforward. Y is equal to x, right? And then we have y is equal to square root of 18 minus x squared. If so far you cannot recognize what this equation is, then square both sides, you get y squared is equal to 18 minus x squared, or x squared plus y squared upon moving x squared on this side of the equation is equal to 18, or square root of 18 squared, right? So what do you get? You get a circle with a radius square root of 18, but we keep in mind that we are talking, the original function was positive square root of 18 minus x squared, so that means that we are talking only about the upper semicircle, okay? So that means y is greater than x, so it's above the line y is equal to x, but is below the semicircle. And then x is between 0 and 3. X is between 0 and 3. So we're talking about this region here. The region of integration is this one right here. Why I'm sure that this exactly point here is 3? Well, if you put y is equal to x and y is equal to square root of 18 minus x squared in a system and try to solve this, from here it follows that x is equal to square root of 18 minus x squared. Square both sides, you get square root x squared is equal to 18 minus x squared, or 2x squared minus 18 is equal to 0. And from here, obviously, you have 2x minus 3x plus 3 is equal to 0. And this factor here gives me the point x is equal to 3. Okay, so now I know what is the region that I want to integrate. Okay, many of you are already comfortable figuring out what is the angle, what is this angle theta right here, by just looking at y is equal to x. So many of you already know that we're talking about pi over 4. If this causes problem to some of you, well, since y is equal to x, every point on this line has coordinates x equal to y, so the coordinates are the same, right? So if this is a length 3, this must be the length 3 also. So these two angles are going to be equal, because this is 90 degrees, these two angles have to be pi over 4, 45 degrees, right? So let's right away write down that here. We know that theta runs from pi over 4, you see, starts from pi over 4 and then goes all the way to pi over 2. Oops, starts from pi over 4 and goes to pi over 2. Okay, and then what is the radius? Well, the radius is straightforward. The radius goes from 0 all the way to here, and this radius is just square root of 18, and r starts at 0 and goes to square root of 18. 18 is 2 times 9, so that's 2 square root of 3. Sorry, 3 square root of 2, my bad. 3 square root of 2. Okay, so these are the bounds for the integral in polar coordinates. Okay, so let's now write all of that together. So the double integral from 0 to 3 and from x to square root of 18 minus x squared sine of x squared plus y squared dy dx is equal to, okay, so first of all, what is the function? Okay, that's what I didn't write. Sine of x squared plus y squared, all of you should already know that x squared plus y squared in polar coordinates is just r squared, so the integrand becomes sine of r squared. Now what is very important is that when you change from Cartesian to polar coordinates, you have to introduce the Jacobian. The Jacobian in polar coordinates is r, so you have dr d theta, where r runs from 0 to 3 square root of 2 and theta runs from pi over 4 to pi over 2. And now this is straightforward. You should be able to solve this pretty easily. This is one of those double integrals where the integrand here is expressed as a product of two functions, both of them defined in independent variables. As you can see, on top of that, the variable here r doesn't depend on theta whatsoever. So if you want, you can write this as the integral from pi over 4 to pi over 2 d theta times the integral from 0 to 3 square root of 2 sine of r squared r dr. That's one way to do it. The integral of d theta is just theta, evaluated from pi over 4 to pi over 2, times, in order to solve this integral, again, I'm just going to use substitution. R squared is equal to u, 2r dr is equal to du, or r dr is equal to 1/2 du. So that's equal times 1/2 integral of sine of u du, and now this is a definite integral, so upon introducing the substitution rule, the limit of integration will change. So when r is 0, u is 0, 0 squared is 0, and when r is 3 square root of 2 squared, I'm just going to remind you that we got this from, that's equal to square root of 18 squared, so you just get 18. Okay, so here I have pi over 2 minus pi over 4 times 1/2 integral of sine of u is negative cosine of u, evaluated from 0 to 18. So pi over 2 minus pi over 4 is pi over 4 times 1/2 times negative cosine of 18 minus negative cosine of 0. And we get pi over 8, right? Pi over 8. Cosine of 0 is 1, so negative 1 with negative in front becomes positive, so that's 1 minus cosine of 18. Okay, the next question says, sketch the solid region S in the first octant. Okay, so right away, the first octant means what? Means that all the variables are positive. That means the first octant, right? Bounded by the coordinate planes, these, and the surfaces x is equal to 4 minus x squared and x plus y is equal to 2. Then set up the integral, don't evaluate it, just set up the integral needed to find its volume. Okay, so first of all, in z is equal to 4 minus x squared, as you can see, we're talking about the surface cylinder y, because here y is free, right? In 2 dimensions, this is z and this is x, 4 minus x squared is going to look like this, right? Inverted parabola, and these are 2, negative 2 and 2, right? So in 3 dimensions, that would look like this. So this is 2 and negative 2, right, along the x-axis, my bad, sorry. And then this extends for all the positive, y. Why I'm taking all the positive y? Because it says y is positive, but I have to also take into the consideration that x is positive, so that means that I'm going to talk only about this portion right here. Okay, so that means that I'm bounded by this wall in the, oops, my bad, this is z and this is y. I'm bounded by this wall, the xy, the yz plane right here, right? So far it looks something like this. So far it looks like this, and then it goes along the y-axis. Okay. Now how about the plane x plus y is equal to 2, or simply y is equal to 2 minus x? In the xy plane, okay, that looks like this. This is the line y is equal to 2 minus x. When x is 0, y is 2, and when x is 2, y is 0. Perfect. Okay, in 3 dimensions, that would look like this. So this is 2, and let's say that this is 2 for y. We have this line here. So this is the plane that cuts this cylinder, right, like this. So this is exactly our solid region that we're looking for. So it looks something like this. And if we pull this outside, we have it right here. Okay, so this is the solid region bounded by the coordinate planes and these this cylinder and this plane right here. Okay, now I have to find the triple integral needed to evaluate the volume of this solid. Okay, so it doesn't specify what coordinate system to use, so we're going to use the easiest one, and that's the, in this case, that would be Cartesian coordinates. Okay, just a reminder that we're talking about the first octant, so that means x, z, and xy. X, y, and z are positive. Okay, so let's see. The order of integration, it's up to you, depends how you will choose to integrate this. Okay, so I'm integrating a 1 because I'm evaluating the volume, dz, dx, the y, one more time. Depending on the order of integration that you're going to choose, the bounds of integration will change. Okay, so y is the most outside integral, so this guy here has to be bounded by constants, right? So what are the limits of y? It starts from 0, right, because it's in the first constant octant, and it goes to 2. So y is bounded between 0 and 2. Okay, y goes from 0 to 2. Now, the x, that means I have to bound x, and the bounds of x are going to be with respect to y. So how does x go? X goes from 0, obviously. Oops, my bad. Nope. Like this, from left to right. Goes from 0. And on the right is bounded by the line y 2 minus x. It's bounded by the line y is equal to 2 minus x, or if I express x from here, is going to be y minus 2. So x is bounded from 0 to, not y minus 2, but 2 minus y, sorry about that, 2 minus y. Right from here, x is equal to 2 minus y. And finally, z, right, it's going to be this interval right here. Again, z is bounded from 0 to this function here, which has to be expressed in terms of x. It's right here, so from 0 to 4 minus x squared. I'm just going to check one more time. Is the question is set up but do not evaluate the triple interval needed to evaluate to find the volume, and here it is.